we're powering through. If you're following along, number 15 on this list of integrals from Princeton, integral dx over x squared of x squared plus 2x. So how do we solve this? Well, I'm thinking in order for a chance to use trig sub or anything like that, the bottom, we need to do something about it. So we can complete the square. Extend this, okay. We can complete the square. So then, that's what I did here. So then I could factor the first three terms as x plus 1 quantity squared, okay? Now I made a substitution. U is x plus 1. Du is dx then, simple enough. So now I get this integral here, du over square root of u squared minus 1. Now this, I can do a trig sub. Set up a triangle. If you're not familiar with how to set the triangle up, I recommend go watching the crash course in trig sub video that I have. All right. So this is the triangle you would get once you set it up. Now we need everything in this integrand in terms of our angle or new variable y. I didn't use theta because again, I got lazy. If you've seen my other problem, I used y instead. So how do we get u? Well, secant y is u. Okay, du is secant y tangent y dy as a result. And then we can substitute the square root term as well. How do we get that? That's just tangent y. Okay, substitute everything. That's what happens in this right here. Simplify it, the tangents would cancel, so you're left with integral secant y dy. This, again, you should just have it memorized. It's ln of secant y plus tangent y plus c, don't forget the plus c. And then we back substitute. What is secant y? That is just u right here, right? Tangent y, that's just the square root term. And then we got to back substitute again. What is u? U was x plus 1. And that's my final answer. So we had to use two techniques here, or three techniques. We got to complete the square first. And then technically you could do a trig sub from here, but I just, for simplicity, substitute u as x plus 1, and then became a little nicer. And then I did a trig sub. So this is one way you can approach this problem. Again, there's probably multiple ways you can do it, but this is how I saw it right away. And I went with it. Especially in a time test scenario, don't try to think too much about it, I would say, because once you start thinking, oh, which method could be faster, that time you spent to think of which one could be faster, you could have spent just solving right away. Okay, so unless it's like really obvious that one technique is more effective than another, like usually a substitution, I wouldn't think too much about it and just straight on go with what you know will likely work.